Welcome to the Curious Dev. Today, we're going to move past all the hype and get right into the nuts and bolts of architecture for truly autonomous AI agents. We're going to focus specifically on the .NET ecosystem and unpack what it really takes to go from a simple chatbot to a system that can reason, plan, and, most importantly, actually do things.
Okay, so let's just dive right in. We've all been using these incredible tools, right? ChatGPT, GitHub Copilot, they're amazing. But here's the thing, they're fundamentally passive. They just sit there waiting for a prompt, and then they spit text back at you. This creates what I like to call a copy-paste tax. You, the developer, you still have to take that code, you gotta integrate it, run the tests, handle the deployment, the heavy lifting, the cognitive load, it's still completely on you. But now, imagine this. What if we shifted from that passive assistant to an active agent? An AI that doesn't just suggest a fix, but actually acts on it. It goes and executes the tests. It reads the failure logs. It refactors the code based on that feedback, and then it opens a PR for you to review. That is the huge leap we're talking about today. So here's our game plan. We'll start by defining that shift from assistant to agent. Then we'll dissect the anatomy of what a .NET agent actually is. We'll talk about the crucial architectural shift needed, see an agent in action, face a much-needed production reality check, and then I'll leave you with a blueprint for building your very first agentic workflow. All right, let's get into our first big topic, the anatomy of a .NET agent. And look, we're skipping all the marketing fluff. This is a practical definition for senior engineers and architects. What really matters are the components you'll be working with in your IDE. So an agent isn't just a raw large language model. You can think of it as an LLM that's been given a few superpowers. First, it gets context and memory, so it actually remembers what happened in step 1 when it's working on step 4. Second, it gets a toolbox full of plugins, and these are really just your own C# functions that you let it call. And finally, and this is where the magic happens, it has an orchestration and planning engine that lets it look at a high-level goal and figure out, okay, which of my tools do I need to use, and in what order to get this job done. Now, in the .NET world, the key player here is Semantic Kernel. It's the open-source SDK from Microsoft that really acts as that main orchestrator. It's the glue that connects the LLM's reasoning brain to your real native C# tools. And you should also keep an eye on the new Microsoft.extensions.ai abstractions. They're aiming to standardize these patterns for enterprise apps, which is going to be a big deal. Okay, now for our third section. And for the architects watching, this is probably the most important one. Building agents isn't just about writing a new class library. It demands a pretty fundamental shift in your architecture. You can't just bolt an agent onto some legacy system and hope for the best. You really have to start designing your systems to be consumable by an AI. And this quote right here, it just nails it. An agent consumable architecture. What does that actually mean? It means you're exposing your business logic, your system's capabilities, through really well-defined, semantically rich functions, what we call tools, that the agent's LLM brain can discover, understand, and then use effectively to get its job done. And this little code snippet from a Semantic Kernel plugin shows you exactly what I'm talking about. See that description attribute? That's not just documentation for another developer anymore. It is the primary instruction that the LLM uses to reason about your code. A detailed, crystal-clear description is what lets that planner decide, aha, this is the C# function I need to call to get the user's order status. But, this power immediately brings up a huge question for any architect. The moment you give an autonomous agent the keys to your kingdom by exposing functions like these, you introduce a whole new class of risk. So how do you build the guardrails to stop it from going off the rails and causing a catastrophe? Well, the answer is to treat agents just like you treat any other user or service in your system. We have to apply the principle of least privilege. This means defining really strict permission boundaries, using role-based access control, or RBAC, but tailored specifically for agents. A monitoring agent, for instance, should only have read access to metrics and maybe the ability to generate alerts. It should be absolutely forbidden from ever modifying configurations or touching sensitive PII data. Okay, that's enough theory. Let's make this way more concrete with a practical, high-value example that I'm sure a lot of us can relate to, an automated exception triage agent. The whole goal here is to automate that really tedious manual process of digging through logs to analyze production errors. So here's how the agent would tackle this. You give it a simple goal like analyze the latest critical errors. From there, the agent builds and executes its own plan. First, it calls a tool you built to fetch the last 10 critical errors from application insights.
Next, it uses another tool to analyze those stock choices. Maybe it correlates them against a vector database of known issues. And finally, it calls a Jira or Azure DevOps plugin to draft a super detailed ticket, complete with logs and its analysis, ready for the dev team to look at. This whole workflow is powered by a cool mechanism called function calling. The best way to think about it is like a conversation. The LLM says, hey, I think I need to run the fetch logs tool. Semantic Kernel's orchestrator hears that, it executes your C# function, and then it hands the results right back to the LLM. The LLM then looks at the logs and says, okay, cool. Based on this, my next step is to call the analyze traces tool. It's this back and forth loop that lets the agent build and execute a complex plan all on its own.
Now, before we all get carried away and try to agentify our entire code base, we need to have a serious reality check. This is Section 5. As senior engineers, our job isn't just to see the cool demo, it's to understand the real world's production challenges. And believe me, with agents, there are definitely a few big ones. I want you to really focus on 3 key production realities. First, latency and cost. These multi-step agent loops, they are not fast and they are not cheap. Every step is another API call. Second is non-determinism. The agent might not solve the same problem the same way twice. How in the world do you write a unit test for that? And third, the classic trap we all fall into, over-engineering. Not every problem needs a complex reasoning agent. Sometimes a simple cron job is absolutely the right tool for the job. This chart really just drives the point home, doesn't it? A single, direct API call is fast and predictable. A multi-step agent loop with all those round trips to an LLM is orders of magnitude slower and more expensive. What this means, for now at least, is that agents are a much better fit for asynchronous, complex background tasks rather than anything that's in a real-time, user-facing request path. So keeping all those challenges in mind, how do you actually get started? That brings us to our final section, your first agentic workflow. How do you start experimenting with this new paradigm without over-engineering something or, accidentally racking up a huge cloud bill? The very first thing to do is to really internalize that mindset shift we started with. We are moving from building tools that assist our developers to architecting autonomous systems that can act on their behalf. Just keep saying it. Chatbots assist, agents act. And here is your call to action. My advice, start small. First, identify one high-value, tedious, but multi-step internal workflow on your team. Maybe it's onboarding a new customer or provisioning a new test environment. Second, start building the C# tools, those individual, well-described functions that an agent could use to automate each step. And finally, use something like Semantic Kernel to orchestrate those tools and let an agent actually try to execute the plan. So I'll just leave you with this one question to take back to your team. Think about your daily grind, the weekly chores, the deployment processes. What is that one task that everyone hates doing that's complex and rule-based, but needs just a little bit of reasoning? Because that right there, that is the perfect place to start your journey into building these truly autonomous systems.
Before you head out, let me leave you with a small ask. If this video made your .NET brain spark even a little, hit that like button. It takes you 1 second.